Okay, so good morning to everyone. My name is Ignacio Labrador Pavon. I'm from Atos Eviden, and I'm representing here the 6G Edge DT project. I'm presenting this decentralized network services orchestration, which is a proposal to integrate what we call sorry? Ah. Yeah, this is a proposal to integrate the stream edge domain, what we call the stream edge domain, we are going to see later on, in the future 6G networks. No, no va. Puedo hacerlo aquí si hace falta. Lo puedo hacer desde aquí, ¿no?
Bueno, vale, ya va.
Ah, ok.
Va un poco lento.
Ok, ok, gracias. Oh, okay, I use the keyboard. Okay, okay. Ah, okay, good, good. Thank you. Okay, so from 5G to 6G, well, this continuum management and orchestration, this is one of the main challenges that that we foresee to manage and orchestrate network services in the future 6G networks. Okay, this is about integrating what we call the stream edge domain. Okay, as we know, in previous generations, what we have here in the figure, 4G, 5G, network services were first developed in the operator's core network. Then, with 5G, we reach the edge network that has been referred here before, using this NFB and SDN technologies, virtualization basically, and programmability. And now, let's say the natural expansion of this is to reach also the stream edge. Okay, the stream edge are all those networks and devices that are beyond the mobile network operator own domain. Okay, so we could have private networks, hyperscalers, multiplicity of devices, and so on. Here I have another slide explaining a bit more about this stream edge and the main features. These stream edge, as we can see here in the picture, include a big variety of infrastructure resources at the, let's say, end user premises. End user is not only individual users, of course. They can be vertical industries or whatever other stakeholders in the network. So it includes a lot of infrastructure resources beyond the operator on domain. We have, as we can see here in the figure, a high heterogeneity of devices. For example, including IoT devices, battery-powered devices, reduced computing capabilities devices, or also other regular devices. For example, some of those devices installed in the industry's premises or whatever. Okay, and one of the main features of these devices, of this new domain, is what we call the high volatility of these resources. They can be moving devices. They can be asynchronously connected or disconnected. They can also unexpectedly change their available resources, the memory, computing resources, or whatever. And they are error prone because they are not in well-controlled premises, like, for example, those devices at the mobile network operator premises that we know they are in a very strict control data centers or whatever. And this is also a massive in a scale ecosystem. This is cloud native. So it is not just the operator on domain is what is outside, okay? And what we want to do here is not just to get data from those devices. This is something that we already do, as we know in 5G. For example, to read data from IoT sensors or whatever, or from the end user mobile devices, whatever. Here, what we want to do is to deploy and orchestrate network service components on those stream edge devices. We want to manage and orchestrate network services, including this, let's say, this new pool of resources that we have outside the mobile network operator domain. This is in connection with the well-known pervasive network concept. This trying to integrate the physical world, all the devices we have around us, to be connected in the network and to be able to execute and run network service components. Why? Because the devices, those devices we have now, some of them, they have non-negligible set of resources. They have a considerable amount of memory or processing capabilities or whatever that we can additionally integrate in the network. Okay. Another consideration we have to take regarding this is regarding the stakeholders, because we are talking about this domain that is beyond the mobile network operator on domain, all those devices outside, but those devices, they belong to someone else, okay, to other stakeholders in the network, that they are also participating in this network continuum, okay? This figure we have on the left-hand side, this is coming from 5G Norma. This is a research project. This is 2017. This is one of the first 5G related research project. And this is a view of the management and orchestration, the view of the management and orchestration scope that we had there. We have the big blue cloud representing an operator, okay? That hosting service provider is representing an operator, a network operator, and the horizontal and the vertical lines are representing the management and orchestration operations, okay? And the color rectangles over there are the network services that are deployed there by means of VNFs, in this case, virtual network functions. And we have some actors accessing those services, okay? We have a couple of enterprises, the green and the red actors over there. And we have also the yellow actor that is another operator, okay? And this another operator is this little cloud here on the right with an independent horizontal and vertical lines with an independent set of management and orchestration resources, okay? So management and orchestration was per operator. The scope was MNO-centric, let's say, okay? This was the view in 5G Norma, the beginning of the 5G research period, let's say. And I have updated this figure with our view towards 6G, okay? As we see here, the little cloud has disappeared. We only have one big cloud that is the entire network continuum, okay? And the network services, okay, they are deployed on this entire network continuum, okay? And the different actors are providing both, are providing the hosting resources, the infrastructure resources, the resources in this cloud, are providing services, network service components, or are accessing those services, are service users, okay? So this is the evolution from 5G to 6G. The main difference is the network is the whole network. It's not, of course, the MNO is still a relevant actor. The different MNOs here contributing here, still relevant actors, but we consider them part of the continuum, together with the hyperscalers, together with the industry providers, together with the end users, even the end users. So this is the idea. And of course, the different actors, they can play different roles. They can be only, for example, hosting providers like this one, or service users, or service providers, or a combination of that. Okay. So how we manage and orchestrate network services in this, let's say, new scope. Okay. What we have on the left-hand side is is a simplification of the well-known ETSI NFB MANO framework for services management and orchestration. Okay, this is coming from 2013, more than 10 years old now. But as we know, it has been the, let's say, the dominant architecture regarding services management and orchestration in the research community and also in the industry, I think. And a lot of research projects and research architectures has been inspired by this architecture. We have the network functions virtualization architecture at the bottom. Okay, this is the physical and the virtualized infrastructure, and on top of which runs the different BNFs, the different network functions that we have represented here on top. And we have this management and orchestration block with all the management and orchestration mechanism to deploy, or in general to control, life cycle control of those network services that we have on the network. But the important thing here is this scope. As we see here, this is per mobile network operator. Okay, so we have a specific management and orchestration frameworks that we deploy on the mobile network operator scope, and then we are able to instantiate and to manage new services on the network. What is the change now towards 6G? I have represented here in this figure. We have introduced two main changes. Okay, one of them is regarding the scope. Is this green cloud I have tried to represent here? This is the whole network continuum. Okay, what that means that now all this infrastructure, the network functions virtualization infrastructure, the physical and the virtualized resources, are those resources in the whole network continuum. Okay, what we have seen in the previous slide, what the different stakeholders are providing, the infrastructure they are providing to the network. So all this is not only MNO-centric, it's the whole network. The same with the BNFs. BNFs are deployed in the different infrastructure components through the continuum. So this is the first change. This is the scope where these MANO blocks are running. The second change is cardinality of the management and orchestration block. As we see here in this red, I have highlighted here in red, we have multiple management and orchestration blocks that are distributed through the network. So infrastructure is distributed and MANO blocks are also distributed. These are the two main changes, okay, that we are proposing here. We have other, what we have in the bullets here at the bottom, other more technological changes, okay? But these are the two main changes. Of course, the architecture is cloud native, is not, is more inspired in lightweight containers and not in virtual machines like that one. It was in 2013, and other things like that, okay? Exposed interfaces and all these new technologies that is state of the art now, okay? But these are the two main changes. So how we want to implement this in practice. Okay. These are the multiple management and orchestration blocks I was referring to in the previous slide. One of them is, let's say, common, and it's called the Common Infrastructure Management and Service Provisioning System. Okay. And the others are, and this is for just for deploying the services on the network, for the provisioning of the services. Okay. And the others, there are multiple, is for service assurance, and these are tailor-made per service. So each service is going to have different service components and a management and orchestration block attached to it, distributed through the network. And this is part of the service. For example, here we have an industry service, AIML, sustainability, whatever, okay, with its own management and orchestration resources and mechanisms. Trying to be lightweight, okay, and tailor-made, adapted to the service. What is inside the common one? Here we don't have the NFB orchestrator, BNF manager, or BIM, you know, those blocks we had in the original ETSI MANO framework. We have defined these 4 new network elements, okay? Deployment node, infrastructure registry node, infrastructure status prediction node, and services registry node that will be distributed through the network, hosted by the different stakeholders participating in the system. Okay? I'm going to explain later on what those nodes they do. Okay? The main one is the deployment node. This is how service composition will work in this deployment node. Okay? This is, for example, the definition of a network service with 4 microservices in this case. This specific MANO block, okay, to control the monitoring or the scaling or whatever other management and orchestration operations are necessary for this specific service, okay? And the different deployment descriptors per microservice, okay? In the different deployment descriptors, we define the requirements for those microservices to be deployed on the network. I want this microservice to be deployed at the core network or of operator A. I want this one to be deployed at the stream edge, but only on those devices that are not powered by batteries. Or I want this microservice to be deployed and attached to this specific subnetwork or whatever. All this is specified here in the deployment descriptors per microservice, okay? So the deployment node receives this information, and using infrastructure registry, information in the infrastructure registry, infrastructure status prediction, the other components in the system is going to do a best match between the requirements and the actually available resources in the network to deploy the service. This is how it works in a very high-level way. Here we have the deployment node, registry service, infrastructure status prediction module, and SRS. We have split the process in 2 main parts. Service deployment, okay, that finish with a service handler. We receive the request to deploy the service here from a stakeholder, and this deployment process finishes with a service handler. Then, using that service handler, the stakeholder or group of stakeholders, they can access to the service to manage the service using the specific management and orchestration resources in that service. The IRS, we can understand this IRS as the DNS in internet. DNS is a distributed database that we use every day to translate IP address and domain name. Okay, but this IRS is a bit more complicated. This IRS is storing specific information of the different devices in the network. If they are battery power, the networks to which they are connected, whatever information that is relevant, and especially for those devices at the stream edge, which are very volatile and disconnect asynchronously. Okay, so deployment node asks to the IRS, ISPM, infrastructure status prediction module. Since this infrastructure is highly volatile, well, this is an optional component. The system could work without it, but this provides additional information to make possible proactive orchestration policies based on predictions. This is AI/ML driven. It makes predictions, for example, to tell you, okay, this device is going to be disconnected in the weekend or during the night or whatever, based on regular behaviors of the devices in the network. Okay, so the IRS gets that kind of information from the ISPM, and this is also used by the deployment node to deploy the service more optimally. Okay, and SRS is just a registry with all the services that are deployed. Okay, I'm not going to enter into details regarding that. So, okay, what we have seen until now is this mandatory management and orchestration set of services, let's say. And these are the tailor-made per service, how this tailor-made per service management and orchestration mechanisms could be implemented based on the state of the art. Some of the state of the art solutions that we already have today. Of course, all those microservices-based orchestrators are applicable here, Kubernetes, K3s. Also, for example, microservice choreographies. We could rely on that if the service, for example, is not very complicated. Instead of having an orchestration framework, we could base on choreographies or other solutions that I have summarized here. The main idea here is not the solutions itself. The main idea is that the intention here is to give the freedom to the service developers to choose the specific orchestration solutions required for their service. Because network services can be very different. Some of them can be very complex and require very strict or complicated orchestration resources, but others, they can be very simplistic, just to get some metrics and some scaling, or that's all. Okay, so here the idea is to give the freedom to have a kind of common set infrastructure resources, what I have explained before, to deploy the network service into the network. And once the service has been deployed, each service is orchestrated, tailor-made, let's say. And this also opens the door to future solutions. For example, when we started developing 5G Norma, the project I was mentioning right before, everything was virtual machines. And now, 10 years later, what we have is containers. Okay, so in 10 years' time, when 6G is a reality, what are we going to have? We don't know. Okay, so we think this approach is open enough to accommodate the evolution of the technology that we may have in the future. This is my last slide. This is just the mapping of these concepts I have been explaining in the 6G DT architecture. Okay. Here in the left-hand side, we can see these nodes I have been mentioning before. Okay, the common management and orchestration components and the functionalities they provide, the device discovery, inventory, to manage this volatility at the stream edge, and then the multiple per services per service instances with the specific management and orchestration resources per service. And that's all from my side. Questions, comments?
This concept of the I think that I think that all people that research contingent about but if we look at the organization bodies that so what is your opinion?
Yes.
Happening, for example,
Yes. Well, standardization in 6G, as you know, they still didn't start standardization at the moment. This is a still very conceptual approach. As you said, well, as far as I know, this started in XIX1, that is the European Commission flagship project for the 6G. And yes, we started considering about this in XIX. And now in XX2, we are also evolving this, and also here in 6G HDT, we are evolving this concept. So still in a very conceptual stage, okay? This is something we are proposing from the research community, as it happened with 5G Norma, for example, years ago, and other projects. But standardization is still one step beyond, let's say. We are not at that stage at the moment. Any other question? Comment? Okay, welcome.